Hey everyone, it's Mike Shaw with Planet for Photographers, and in this video tutorial we're going to talk in detail about how to avoid star trails in your starry sky night images. Star trails are when stars appear as lines instead of points, and they occur because of the motion of the Earth. One way to avoid them, of course, is to use an equatorial tracking mount, and then blend the result with an untracked image of the foreground. That method involves more work. This tutorial is on how to avoid star trails in the first place in single exposure images with no tracking. The key is to keep your exposure time less than some maximum value beyond which star trails start to become noticeable. The name of the game, however, is what do we mean by noticeable? Sounds good? Let's get started. So as a refresher, it's helpful to remember that not all stars travel at the same speed. Facing north and south, stars move much more slowly than facing east or west. It's pretty simple, really. Stars moving in the east, rising in the east, they have to travel much further in the same amount of time as stars in the south or the north. Consequently, stars rising in the east or setting in the west have greater speeds. So all the maximum shutter speeds we're going to be talking about here are the worst case, in other words, for situations where stars are moving the fastest. You may very well find that you can exceed these maximum shutter speeds for compositions that only contain slow-moving stars. Alright, to begin with, swipe down to show the ephemeris page chooser. Tap the first option under night photography to select stars and star trails right here. Then tap this toggle button up here to switch from Star Trails mode to the Avoid Star Trails mode. Now here you see the 500 rule, and what that means is if you want to take a starry sky photo without seeing any star movement, the maximum shutter speed should be no more than the number 500 divided by the focal length of your lens in millimeters. For example, let's change the focal length to 14 millimeters. You can see right here that according to the 500 rule, a maximum shutter speed duration equal to 500 divided by 14, or 36 seconds, should allow us to avoid any noticeable star trails. But when we actually use this shutter speed and lens combination, or any maximum shutter speed given by the 500 rule with today's cameras, star trails are actually quite obvious. So we actually think the 500 rule is a little outdated. But why did people develop the 500 rule in the first place? Well, the maximum ISO in older cameras wasn't especially great for night photography, and there weren't the same high-quality fast lenses available. And the resolution of images at the same time wasn't that high either, so any star trails were much less obvious than with our high-resolution equipment today. So through trial and error, the 500 rule evolved to give night photographers the best trade-off between noticeable star trails and enough exposure for a decent image. So with the advance of modern photography technologies, today we can do much better than the 500 rule, and that's why we introduce a few more options for you here. Tap on the 500 rule. The first one is the Circle of Confusion, or COC rule. Tap on it. The COC rule was invented by Wenji Chao of Planit, as you can read about here, and the theory behind this rule is to consider the maximum angular speed of the star so that it will not show up in two adjacent pixels on your camera's sensor. If you select the COC rule, for example, for a 14mm lens, the maximum shutter speed is only 21 seconds instead of 36 seconds. For a 24mm lens, it's 15 seconds, as you can see here, and let's change it to a 35mm lens. And now you can see it's 11 seconds. Okay, so does the COC rule prevent star trails completely? Well, no. I mean, any rule here is a compromise between enough exposure and star movement. Unless you're using an equatorial mount, as I mentioned earlier, there's going to be star movement even if you just shoot for a second. Still, with modern camera and lens systems, we can get enough exposure with even shorter shutter speeds. So now, let's introduce our third rule, and that's called the Npf Rule, invented by Frédéric Michel at SAH, as you can read about here. The key difference is that in addition to the focal length, the Npf Rule considers the effects of the aperture as well. Alright, so let's take a look and see what the Npf Rule gives us. If we're using our 14mm lens at f1.8, the maximum shutter speed is now only 14 seconds, even shorter than the COC rule when it was 21 seconds. What's interesting is that when you change the aperture, the maximum shutter speed increases. For example, when we change the aperture to f2.8, we get 16 seconds, and if we go ahead and change it now to f4, it's 19 seconds, almost the same as the COC rule. Okay, how about if we change the focal length of the lens? Let's see what that does. So let's change it to 24 millimeters, and we get 11 seconds. Let's change it to 35 millimeters. We get 8 seconds. All are shorter than the values given by the COC rule. Now, since the Npf rule depends on the sensor resolution, you can make sure you've set that correctly by tapping here and selecting Settings. You'll then see the camera settings, including an option for the sensor resolution right over here. Now, here mine's set to 45.7 megapixels, for example, for my Nikon D850. You can enter the appropriate value for your camera like this. Let's say, for example, we want to enter 35 megapixels. Now, if we can go back and take a look at the results, let's say, for example, the 14 millimeter lens. It is now 21 seconds. You can remember that it was 19 seconds for a 45.7 megapixel sensor with the Npf rule at the same aperture of f4.0. Okay, what happens if we change to a larger resolution, let's say 100 megapixels, just here as an example. Okay, now we get 16 seconds instead of 19 seconds for the 45.7 megapixel. So there's quite an effect. Let's go ahead and now change our sensor size back to 45.7 megapixels before we forget. So now you may have a question. Why are there so many choices or rules for a maximum shutter speed to avoid star trails? Which one should you use? Well, the answer is that it really just depends on your camera and your lenses. What works for one person may not work for another. This way, with different options, you can select the best rule that works for your particular camera and lens combination. So let's say, for example, the maximum workable ISO of your camera is around 3200, and your minimum aperture of your 14 millimeter lens is f4. So in this case, the 500 rule is going to be just fine. Here you can keep your shutter speed to anything less than 36 seconds. And let me show you why. Let's now switch to the exposure page, and we'll set the ISO to 3200, the aperture to f4, and the shutter speed to 30 seconds. With these exposure settings, you can see the EV is negative 5.9. By contrast, the typical EV needed for a starry night or a Milky Way shot is between negative 6 to negative 8, which means the exposure settings we're using should be negative 6, negative 7, or lower. Well, negative 5.9 is pretty close to negative 6. If we actually set the EV to negative 6, the shutter speed should be 32 seconds, which is pretty close to the value given by the 500 rule for this focal length. And that's exactly why it's better to use the 500 rule if you have an f4 lens and a maximum workable ISO of 3200. Okay, so when's it necessary to use the COC rule instead of the 500 rule? Well, recall that the maximum shutter speed is 21 seconds with the COC rule for a 14 millimeter lens. Let's go back to the exposure page, and we'll change the shutter speed to 20 seconds to match with the COC rule. And then we'll change the aperture to f2.8. And what we see is that the camera's EV at these settings is negative 6.4, and that's good enough for starry skies. Remember, we just need an EV between negative 6 and negative 8. So, what's the bottom line? Well, what this all means is that if you have an f2.8 lens, it's better to use the COC rule than the 500 rule. Okay, so when should we use the Npf rule? Answer: when we're using extremely fast lenses. Recall that according to the Npf rule, for a 14 millimeter lens with an aperture of f1.8, our maximum shutter speed is only 14 seconds. Now, going back to the exposure page, and changing the aperture to f1.8 and the shutter speed to 13 seconds, which is even less than the 14 seconds determined by the Npf rule, we see that the calculated EV is -7, which is exactly in line with the EV needed for starry skies. Alright, so now let's go one step further in quality. Go to the settings under the Npf rule choice, and you'll see a new option for large prints right here. Now, generally, if we shoot a photo and we don't print it, we don't need it to have the highest possible resolution, especially if it's going to be mainly viewed on your computer or mobile device screen. But if you want to make a large print for display, you'll notice the difference because large prints use a much higher resolution, or dots per inch, or DPI, than the screen resolution. Consequently, in order to avoid star trails in large prints, we need to use an even shorter shutter speed, and that's what this option is for. So if you do need to print in a large format, check this box. Now let's go back and take a look at what's changed. Let's start by looking at the result of the COC rule first. And this says 6 seconds max for a 14mm lens. Remember, it was 21 seconds, and now it's down to just 6 seconds. This has been reduced by almost a third. The same thing with the Npf results. 7 seconds, almost the same as the COC rule. So, for large prints, the new requirement for 14mm is only a 6-second maximum shutter speed. Well, is it even possible to get a good image at such a short exposure time? Well, let's look at the exposure again to find out. We'll change the shutter speed to 6 seconds. And the EV is only -5.9. It's barely good enough. But we can bump up the ISO to 6400, and that gives us an EV which is -6.9, which is now plenty good enough. So now you can see why making large prints is better with a good camera that has a nice high ISO along with a fast lens. When both of these conditions are met, we can use really either the Npf or the COC rule with the large print option turned on. Alright, so hopefully now you understand what the large print option is for. Let's go ahead and switch it off again for now. Now, in addition to the large prints option, there's another new advanced option, the Diffraction Limited Aperture option, or DLA for short. Now, the DLA wasn't really that important before, since the earlier sensor resolutions weren't as high as they are today. Each pixel on the sensor was relatively large, so diffraction of light had no effect. But since today's sensor resolutions get higher and higher, diffraction becomes more and more of a problem. And if you're interested, you can Google DLA to find out more example about it. Here, I'll just give you the conclusion by way of an example. Let's suppose that we're using a camera with a 45.7 megapixel resolution. You can see right here that the DLA is f6.5. What this means is that if you're using any aperture smaller than f6.5, like f8 or f11 or more, the picture quality is predicted to begin to deteriorate because of the effects of diffraction. And we know diffraction can be a problem. It causes a softening or a blurriness of images that can become quite noticeable. Now, for landscape photographers, we all know that the ideal aperture, or the sweet spot for landscape images, is generally around f8 or f9. So let's step back a little bit. f6.8 is a little strict. Let's loosen it up a little bit and reduce it by half. Let's say f13.6. Then the effect of diffraction is still okay. In other words, any apertures larger than f13.6 are fine, like f8 or f11. So what this means is that apertures of f8, f9, f11 can still be used for 45.7 or 42 megapixel cameras. But however, if you further increase the sensor size, let's say we go all the way up to 100 megapixels, now the DLA is f4.4. But again, even if we reduce that by half, we still have f8.8, so f8 would be the smallest aperture you'd be able to use with a 100 megapixel camera, but not really f9 or f11. Okay, finally, what about a 22 megapixel sensor like the Canon 5D3 or 4? Here, the DLA is f9.3, so if we again reduce it in half, we get f18.6. So in this case, f16, f11, and so forth are all good, just not f22. And this is why so many articles suggest not using f22 for landscape images. And right now, the 42 megapixel is a popular sensor size, so f8 and f9 are still the ideal apertures for landscape images. So if the best possible picture quality is your goal, just avoid f22, f32, and other small apertures. So let's go ahead and return the sensor size to 45.7 megapixels now. Okay, at the very end of this tutorial, we'll include a link to an article about the DLA if you're interested. But if you just want the conclusion, this app is good enough. But if you want to know the theory behind it, you can read the article. Okay, so that's how to avoid star trails in your starry night images and produce the best quality images for large prints. Thanks for watching. This is Mike Shaw with Planit saying until next time, best of luck planning with Planit.